Hey, what's up, everybody? Alright, it's a new day. It's Tuesday. And 10:32. We're gonna start doing a little bit of programming today. Candle just went out for no reason. Don't know why. Guess it's running out of wick or wax rather. Come on, candle, come back. Is he dead? Might be dead. Oh well, let's get a new one. Anyway, alright, so yeah, we're gonna crank up today. We were doing benchmarking yesterday for Pickle SQLite to make our final decision for which one we're gonna go with. Let's check our extensions. There we go. We gotta restart VS Code Pets because how would we be able to code without our little cat down here? Well, I don't even see it anymore. What happened to our little cat? It's gone. Oh well. I mean, there they are, but where is it? Well, I don't know. It's not a big deal though. Life goes on. Okay, so we did the benchmark yesterday in test reminders that Claude actually made this benchmark and it's pretty awesome. It didn't have any errors, no syntax errors. Damn, that's impressive, not gonna lie. 0 syntax errors in what, like 100 something lines of code, making me look bad. Yeah, SQLite made this, Claude made this in like 10 seconds. So we ran the test yesterday and we learned that, let's go ahead and just run it real quick. Control F5 to run it. Alright, so it's testing full pickle. Writes per second is 20 to 37. So that's going to give me the summary. That's what I want to see. So full pickle is 20 to 37 writes per second, which is crazy fast. Partial pickle 2143 writes per second, crazy fast. SQLite individual 152 writes per second, way slower. We're talking like 10 times, 15 times, 12, 13 times slower. Very slow comparatively to pickle. And SQLite batch is actually really fast. SQLite batch was almost as fast as pickle, but that's the question is which one are we going to go with? Well, we also wanted to check shelve. We wanted to check shelve and we wanted to check the SQLite library, not SQLite library, what is it called? SQLite, where is it? SQLite dict versus shelve. So let me just think about this for a second, make sure I'm on the right page here, because I don't really want to waste any more time on this. I've wasted a lot of time. I mean, I wouldn't necessarily say it's a waste of time, but I would like to move forward with the project, you know. I don't really want to learn every single thing that I need to learn. Or, not that I need to learn, that I could learn. I really only want to learn what I need to learn. I don't really want to waste any more time on. Yeah. So, alright, so we have SQLite dict versus shelve, blah, 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 blah. And so for the requirements that we have, we only are going to do 5 to 15 writes per second. Most likely, I would say. Maybe 20 at the highest. So I would like to think, oh yeah, I forgot to set our timer here. Let's go ahead and set this. 4 minutes. Alright. 64. Alright, there it goes. Timer set. Yeah, so it only need, the 20 writes per second, and SQLite would absolutely be great for this. There would be no reason to use Pickle. Well, I mean, I guess you could say it would improve the performance of the game because, yeah, it would improve the performance of the game. It would be a lot better. And honestly, based on the speed of it, we could just, we could literally, well, we're worried about file corruption. We could just have a backup file. But remember, we couldn't use full pickle because we need to access individual attributes. So we have to use a system that allows us to access individual attributes, which would be the partial pickle option or SQLite. So we really couldn't use full pickle. SQLite is very secure. Batch option. I mean, well, SQLite in general is very secure, and the batch option allows us to increase the speed greatly. So commit apparently counts for a large portion of the computation, because if we look at the results here, individual SQLite was 152. Let's see. So SQLite batch does, let's see. Okay, so it does 10 writes. Well, it does 10 inserts per one commit, and that compared to one insert per commit right here. So we have execute, insert, and then commit immediately after. That literally is 10 times slower. So almost all of our time is commit. Like commit is what slows it down. Because when we do commit every insert, it's 10 times slower. It's actually more than 10 times slower. But when we do 10 inserts per commit, it's 10 times faster. So that leads me to believe that commit is like, what, 90% of the time of this operation? You know what I mean? So I would like to know a little bit about that as to why that is the case. Why this takes so long. Why does insert why does a benchmark wherein we do 10 inserts per commit, why does a benchmark wherein we do 10 inserts per commit perform 10x better than another wherein we do 1 insert per commit? The performance difference is due to the overhead associated with committing a transaction in SQLite. Here's why committing every 10 inserts is significantly faster than committing every single insert. So the transaction overhead, each commit in SQLite requires ensuring that all changes are safely written to disk, which involves file system synchronization, fsync. This is an expensive operation. When you commit once every 10 inserts, you amortize this cost over multiple operations, making each individual insert effectively cheap. WAL mode versus default journal mode. If you're using SQLite's default rollback journal mode, every transaction, even a single, insert followed by a commit requires writing to a journal file, modifying the database, and syncing changes to disk. In contrast, using write-ahead logging mode can improve since commits don't require as many costly disk syncs. Okay, so is WAL mode so how do we enable WAL mode? I want to see if this is going to make a difference here. So we're looking for SQLite. We have. So that's what we need to know. Let's continue locking overhead. SQLite locks the database during transactions to maintain integrity. If each insert is its own transaction, SQLite has to acquire and release the lock every time, adding extra processing time. By batching inserts in a single transaction, you reduce the frequency of locking and unlocking operations. Writing to disk. The operating system can optimize larger batches of writes more efficiently than frequent small writes. So we'll commit every 10 inserts allows SQLite and the OS to optimize how data is written, reducing the number of disk seeks and increasing throughput. Instead of committing every 10, try committing every 100 or 1000 inserts. Use WAL mode. Running Pragma journal mode equals WAL can significantly reduce commit overhead. Disable synchronous writes. Risky. Running Pragma synchronous off removes fsync operations, making commits nearly instant, but at the risk of data corruption. So use execute many for bulk inserts if applicable. Cursor execute many can speed up inserts. Okay. Do we have to use Pragma journal mode equals WAL only one time? Only one time. 2. How risky is Pragma synchronous equals off? So that removes file sync. So fsync it said was file system synchronization. Safely written to disk. It's an expensive operation, which means basically like it's not gonna get corrupted. But I would just rather it be so fast that like that in it of itself would avoid corruption, right? You know what I mean? Like, because I'm guessing what corruption means is the risk of file corruption associated with the fact that data is still being written at the time of some form of interruption. You have to use Pragma journal mode equals WL. Then one time, how risky is Pragma synchronous equals off. Is the risk of file corruption associated with the fact that data is still being written at the time of some form of interruption. So ChatGPT sometimes is really laggy. I don't know why that is, but that's just the way it is. So let's run this. Let's go over here. We're gonna add in this Pragma. Journal mode equals WAL. I don't really know what that means. Do we have to use pragma only one time? Yes, with caveats. Persistent setting. Once you set... Okay, so yeah, ChatGPT is doing this thing where it's really slow. It does this sometimes. So like, would we just run this straight up like this? Yeah, that has to go in some sort of context. Persistent setting. Once you set pragma journal mode equals to be able to sort in the database file and remains in effect to explicitly change it. So you have to. I see. You would bring it down. Table, and then I guess. Yeah, I don't know the syntax for this. I would have to figure it out. When you say pragma journal mode equals WL, it is stored in the database file and remains in effect until you explicitly change it, e.g. back to delete or truncate. Per connection requirement. However, pragma statements apply per connection. If your application opens new database connections, they may not inherit the WL set. Explicitly execute pragma journal mode again on each new connection. Pickle had the highest protocol. That would ensure that Pickle's the fastest. Okay, check current mode. You can verify if WAL is properly set. Okay, yeah, this is so slow. I'm gonna have to open up Claude over here. Say, how do I set with SQLite 3 Python? Okay, using SQLite 3, here's how you can do it. Okay, so we have connection, example, connection, execute. So it's really that simple, bam. We just do set the journal to the rest of your database operations. Cursor equals con cursor. Where's merge commit and close the connection. So WAL mode can significantly improve performance, especially for write-heavy applications. It allows multiple readers to access the database simultaneously while a write is in progress. Okay. The setting persists for the current database connection. And if you want to verify the journal mode, you can check it like this: cursor.execute, and then you'd execute it and check it. Oh no, you would just say cursor execute pragma journal mode, and then cursor fetch 1, and that will get the thing returned by the database. So it's returned WAL successfully set. If you best practice set WAL mode after opening the connection but before any other operations, use concommit to ensure changes are saved. Close the connection when you're done. So ideally you would change WAL and then commit and then do the rest of DB operations, or could you set WAL, then do DB operations, then and it would still end WAL. Both approaches work. You can set WAL mode and then immediately start database operations, commit later. WAL mode would be in effect for all operations. So if you were to do connect, set WAL mode, then do executions before you did a commit. The key point is that once you set WAL mode, it's active for that connection's lifetime, regardless of when you perform operations or commit. Okay, so you don't have to commit immediately after. just write con execute pragma journal mode equals WAL. So we'll go over here. Let's see. And I guess we could do this on one line. Just say self-con execute pragma journal WAL. And there you go. Now you can do we can get it to return value by saying self.con execute. Oops, that's because I'm looking at the wrong one. So this one, we want cursor execute and then cursor fetch 1. So if we do like such, cursor, like what is cursor? Cursor has to be equal to something. So equals con cursor. And that's a method. Okay, so then, yeah, we have self-con execute pragma journal mode equals WAL, cursor equals con cursor. This is going to be self-con. Cursor execute pragma journal mode, and then print cursor fetch 1. That's going to return the state of it. And we'll do the same thing here for, let's see. This, do that, copy this, and we'll bring it over here to SQL batch. So we have con equals this. Then we have self-con execute pragma journal mode equals WAL, cursor equals self-con cursor, cursor execute pragma journal mode. So this, and then we do print cursor fetch 1. That's going to return the mode, the journal mode. So now if we run both of these again, or this test again. Okay, so we do get WAL, so it is correctly, so we can get rid of these 3 lines. Now we go up here and we can get rid of these 3 lines as well. We can get rid of, there we go. So we just have the con execute pragma journal mode equals WAL, then con execute, same thing down here is con execute pragma journal mode equals WAL, and then, well, then it's the batch size, and then another execute. Okay, so we do, alright, so now let's run this test without the prints. Let's see what our final values are. We got 23, 1900, SQLite 517, but 64, 70. So then if we disable wall mode, so we had 517 and 65. Now let's test this. $540 and 7,000, so it's faster without wall mode. I guess it's not really utilizing wall mode, maybe. So we are getting some wildly different results. But it looks like all of a sudden, I don't know why exactly, but it looks like batch SQL way faster, and I don't know why that is. Is it still in wall mode? Is that why? Let me see. So if let's see. If I comment this out, alright, now if we run this, so they're still both in wall mode. So they're still in wall mode. But wasn't SQLite individual faster before? No, it was slower. It was only 150. And then after it went up to 6. So it went from 150 to 650. That's an insane difference. Yeah, so it's way faster in wall mode, and it's already set because I guess the database file configured it that way. So it's like it's already, it doesn't matter if we set it again, it's already so actually with these changes, SQLite batch is just way faster. Insanely faster. Like not even a joke. So we're getting 7,000 instead of 2,000. So it went from the first test with wall mode disable. It was 1,800, which was slower than which was a little bit slower than both pickles. But now SQL is faster with WAL. So that looks like, well, yeah, that means there's no reason for us not to choose SQL at this point. If SQL is faster than pickle, which I don't understand how that could be. Well, it's okay, so it's because of the way that it writes to the file, apparently. I guess, I don't know, it just uses some sort of something that's really fast. So there's no reason for us to check shelve at this point because SQLite batch is just so fast. And if it can handle all of the writes per second, like But remember, it will still individually, the code, that the way it's coded is it will still individually write even when it's it will still individually write and commit instead of batch writing and committing in the case that there's only one attribute slash data point in the batch. Isn't that right? Yeah, SQLite batch state. Let's see. Write adder variable pickle dumps. Your subcurrent batch is equal to 0. Begin transaction, execute, insert, replace into. So we insert, replace into state entity ID, adder value. Then we say subcurrent batch plus equals 1. Okay, no, so this one actually only does batch writing. It doesn't allow for it doesn't allow. So this actually wouldn't be good for us per se, because you know, it might take us a little while to get 10 things changed, you know? Well, what if we change the batch size to just 2? If we change the batch size, let's change the batch size to 2 instead of 10. So every 2 instead of 10. And then let's run it now. So it should be, batch should be way slower, but it should still be pretty fast. Okay, yeah, so it's still way fast. Even though the batch size is only 2. How is that right, though? I thought that this basically... Let's do this again. Okay, let's do batch size equals 1. If we just do batch size as 1, this should be basically individual. Something's not right here. Why would batch size 1 not... I don't know. I don't get it. Why is the SQLite one so... Why is the individual SQL so much slower? Oh, it's because it's not pickling. How is it working then if it's not pickled? No, it does. It does. It does. It does pickle it. I don't understand. I really don't. I really don't understand why. For name handler and handlers items. Handler right adder player 1 score 100 plus I. I don't understand. I just don't get it. How is this batch size equals 1? All right, let's try this. If we do batch size equals 0, now let's do it. Okay. What we're gonna do? I got you. I got you. How about this? We're gonna copy the right adder. We're gonna bring it down here. Okay. Now we're gonna run it again. Now let's see what we get. Okay, so this time it was actually what I would expect. Yeah, they're the same because they're using the same attribute. So it's something within this right attribute that is making it so much faster. And I just want to compare them side by side. Let's just compare them side by side here. Because this is getting to me. Self entity ID string, adder string value any, value blob equals pickle dump value protocol equals pickle highest protocol. Alright, and the difference here is we have if self current batch is equal to 0, which it will start off as 0, does self con execute begin trend. And then we have self-con execute insert replace into state. Oh. So the difference is the begin transaction? Is that it? So in one of them, we're beginning the transaction, and the other one, we're not. If I'm understanding this correctly. That's the difference here. Gotta stretch my back out, sit a little different. Because my back's bothering me, something like that. Okay. This is insanity, dude. You're telling me that... So, does it being in wall mode and us doing the begin transaction, is that what allows it to be so much faster? And this is indented incorrectly. This needs to be like this. There we go. Because, yeah, value blob is the same, but and then the difference is in the right adder from above for the single transaction, we have con execute, insert, or replace into, and then the commit. But in the other operation, so let's modify this. Let's not even worry about current batch at all. Let's just have a straight up begin transaction, then the execute, then the insertion, and we're not even gonna have the current batch shit. We're not even gonna worry about that. We're just literally gonna turn it into a single transaction thing. So now it just does value blob, execute begin transaction, execute insert, then commit. There's no difference from the single transaction other than the fact that we have begin transaction. And that doesn't increase the speed. So that is strange to me. Oh man. Ha. Oh no. So now it's the same basically. And I'm just wondering, were we getting skewed results? I don't know. I think we might have been getting skewed results. I don't think that was necessarily like working correctly. Yeah, something's wrong. It's skewing this data. There's no way. There's no way this is right. The SQLite batch results are right. There's no way, because there is no real difference between these two. I don't believe that they're actually that much batch is that much faster. Because the only difference is we have value, we do begin transaction. First of all, what does begin transaction? Because I'm not gonna lie, it's kind of pissing me off here. Right, if you want to speed up writes without extreme risk, consider these options. This is correct. Let's use Pragma. Do we have to use Pragma journal mode equal to super connection? Check current mode. I risk use Pragma synchronous off. Setting Pragma synchronous off is very risky because it disables Epstein calls, meaning SQLite the data is physically to the disk for considering a transaction committed. Risks: power loss or system crash. If the system crashes before the data is fully written to disk, the database file may become corrupt, potentially making recovery difficult. Loss: a transaction might appear committed, but can be lost if the OS hasn't actually written the data to disk yet. A transaction might appear committed, but can be lost if the OS hasn't actually written the data to disk yet. If using WL mode, the risk is slightly lower as SQLite keeps write ahead log. Chances of full corruption. Still lose recent transactions. Yes, exactly. Is the risk due to data still being written? The OS typically caches disk writes before flushing them to storage. When synchronous is equal to off, SQLite doesn't force an immediate disk sync. So if an interruption occurs, power failure, the database file may be left in an inconsistent state. If you want to speed up writes without extreme risk, use pragma synchronous equals normal. This is the default in WL mode. It avoids excessive fsync calls, but still maintains reasonable safety. It's less safe than full in case of crashes. WL mode plus batch. Every n inserts. That's what we're doing right here. How come this one doesn't have the begin transaction? So here's what I'm gonna do. I'm just gonna copy this. I want it to tell me what the difference is between these two. Well, you know what? I'll just copy this whole little thing. And I want it to tell me why that would be so much faster. So we're gonna just say, go. Between these two, why would the lower option be the second option be 5 to 10x faster? Should it be? Should it attain 6,000 writes per second while the first only gets 700 writes? The difference between these two implementations is transaction management. First option, commits after every single write, commits each write individually, higher overhead due to frequent commits, lower performance. Second option uses transaction batching, begins a transaction, accumulates writes up to batch size, commits in batches, significantly reduces commit overhead. The performance gain comes from reducing disk I/O operations, minimizing transaction overhead. The batch commit optimizations. But why would it still be the same write speed even if I change batch size to 1 or even 0? Wouldn't that basically same the first option is doing? It's about the batch size, but about using an explicit transaction. The SQLite batch state class, the key optimization is the begin transaction statement. Even with batch size equals 1, you're still using an explicit transaction, which reduces the overhead of operations. When you use begin transaction, SQLite defers writing to disk. It reduces synchronous write operations. Batches multiple writes together. So even if batch 1 you see performance closer to the batch version. From the transaction management. Yes, I don't understand why the second option would be faster even with singular data point change per commit, just like first option. The key difference is in how SQLite handles transaction. So Each concommit forces an immediate disk write, high overhead due to synchronous writes. Each write requires full disk synchronization. Second option is an explicit transaction. Tells SQLite to batch writes. Defers actual disk writes. Allows SQLite's internal optimizations. Uses system call and disk synchronization overhead. Size equals 1. The explicit transaction provides significant performance benefits to optimize write operations internally. No, I don't understand. I just don't get it. I don't get why defers actual disk writes. What do you mean that begin transaction defers disk writes? When you use begin, it doesn't immediately write changes to disk. Instead, it changes are first recorded in memory. Disk writes are postponed until commit. Yeah, but if you're committing every one anyway, how is it different? See, like an optimizing group multiple writes. System call. See, like an optimizing writes reducing organization. Operate. First of all, what do you mean by synchronization operators? And then two, but even with a batch size of one data change per commit, just like the first option. It's still way faster. This means not actually committing each change like the first one. Because look at it, does insert place into state and then commit, and this one does begin transaction. But if the batch size is 1, let's verify this. Is batch size equals 1. Run it. It's still like 10 times faster. In this case, it still does begin transaction every, so it's actually every 2, because the batch size is equal to 1. So it would say if current batch is equal to 0, it would begin the transaction. It would insert, it would change current batch to 1, and then it would say if current batch is greater than or equal to batch size. So actually, yeah, it would, on the first one, it would enter into this and commit. So literally, this is this. There's no difference other than begin transaction. So I don't. That's what I don't understand. Even though commit would run just like the first option. Your system allows less overhead for write, more efficient use of disk I/O, different for batching multiple writes together. It comes from this deferred optimized writes strategy. I still don't understand why begin transaction makes it so much faster, despite still coming each 1x Data change. Desynchronization means forcing the operating system to write data from memory. Desynchronization means forcing the operating system to write data with physical disk storage. So it makes it go from memory to disk storage per operation, as opposed to letting it accumulate in memory and then like synchronously writing it to the disk. Requires mechanical disk movement. OS must ensure that data is safely stored. The key is that begin transaction changes how SQLite handles the write, even with batch size equals 1. Without begin transaction, it will write data, force to disk for completion. Begin transaction, it will write the data, store in SQLite's WAL file, and continue immediately. Okay. See. Okay. I understand. Even though both commit after each change, the second approach uses WAL file more efficiently. Prefers actual desynchronization. Allows SQLite to optimize write patterns. Just waiting for physical disk operation. So yes, it's still committing each and doing it more efficiently through transaction. Gotcha. Okay, I see now. What is the file? Is that the actual? Okay, now I'm understanding this now. So it's not a skewed result. This is actually how it works. It's that much faster when you use So I guess begin transaction is associated with WAL mode. So is begin transaction only associated with WAL mode? 30 file is separate from the main database file. When using WAL mode, the main database file contains the core data. WAL file contains recent changes. Changes are first written to the WAL in a fast mode, and then it's later merged into the DB file at a checkpoint operation. Okay. Improves write performance. It allows concurrent reads while writing. Complicated type shit, but okay, I understand now. This makes sense to me. Because begin transaction only associated with WAL mode. The begin transaction works with any SQLite journal mode, WAL, delete, truncate, etc. It's a separate feature that manages how changes are written to the database. Okay, so what's the downside of the transaction? The downside of the begin transaction is memory usage increases since changes are held in memory. Risk of losing uncommitted data if program crashes. Risk of losing uncommitted data if program crashes. Can cause database lock contention with other connections. Large transactions can impact database performance. Need to ensure proper transaction management. Begin, commit, rollback. Main trade-off is between performance and data safety. Fast writes, but higher risk if something goes wrong before commit. Okay, so ultimately, if we only need 5 to 20 writes per second, and without in transaction we get 700 per second versus 6,000 per second. Enabled. It be worth use. Enabled mode. No, using begin transaction wouldn't be worth it for your only 520. This basic 700 check is what the simpler implementation with immediate commensurate safety without any impact for your workload. So this wouldn't impact game performance. This was going thread as a save file system. The 6,000 benefit us. For a game save system, the higher write speed likely will provide meaningful benefits since save operations are typically infrequent. No. It's already fast enough to impact game performance. It's more important. It's the write speed. Right, so that's just like how fast it can go. Memory usage and crash risk from begin transaction isn't worth it for save data. The extra memory usage and crash in transaction worth it for system. Okay. So there it is. Settled it. We can just use the SQLite individual. Straight up SQLite. Or we could use that partial pickle thing. So, yeah, I think what we'll probably do is we'll go with the we'll probably just go with SQLite individual for the security. Partial pickle. I mean, we could do partial pickle. So it's really down to partial pickle versus SQLite individual. Yeah. Oh yeah, but without WAL mode. Let's see. If we disable WAL mode and then we delete these oh, it's way slower. It's only down to 151. Before it was I mean, I would think to use begin transaction though, just because of it seemed write data store in SQLite while file continue immediately. And it's like 5 times faster, so I would think like so fast that I just feel like if it completes it so quickly. But we want the most secure. So I would say we should probably just go with the most secure. So how dangerous is WAL mode concerning corruption? That's really what I need to know. Is it worth the benefit? Well, mode is generally very safe against corruption. Atomic rights prevent partial updates. Original data preserved until WHL changes are complete. Parallel typically only uses uncommitted transactions. Main database is attacked, even if corrupts. Okay. That opposed to using pickle files, many individual pickles. Is it much more secure? So play with the VOs much more secure than individual files because atomic transaction, built-in crash recovery, all or nothing against single file. Easily vulnerable to partial writes, corrupting data, race conditions during writes. No atomicity guaranteed. Harder crash recovery, file system fragmentation. Okay, yeah, I think we're gonna go with SQL. I just like the idea of it. I mean, pickle's cool and that's all. It's fast, whatever. But like the security of SQL, so that's gonna be our final choice. We're gonna go with SQL. We're gonna use write ahead logging. But I don't know if we're gonna use begin transaction. Begin transaction. I actually think I would use begin transaction. I think I would. Yeah, I would actually use begin transaction. Explain this same scenario for WAL instead of begin. Explain the same scenario. The same language example. For WAL. So without WL mode, you would do write data to main DB file, force sync to disk, wait for completion, continue. data into WAL file. Continue immediately. Later, background merge WAL into. Let's write continue without waiting for disk sync. These are safely logged for link. Okay, so we're gonna use WAL and we're gonna use begin transaction. We're gonna use both. We're gonna have the lightning speed capability here for write speeds, which in my mind is like, if a crash happens, it's gonna happen like the data's gonna be written so fast that like it's not even gonna be able to catch it. You know what I mean? Like the crash isn't gonna be able to fast enough to stop the process. As to where if the process is longer, more secure, the ultimate end result of data security is gonna be basically. So yeah, we're gonna go with SQLite. SQLite individual wall mode with transaction. So let's put that in here. We're gonna say decided on implementation of save file system, and then we're going to use SQLite with WAL and begin transaction modes. Allows for stream fast writes and good file security and individual adder lookups overwrites. Boom. And we wanted to use a database in the first place, remember? So now it's 11.1. We did, we continued putting to determine. Did more of that. Did an hour and 19. So we'll say an hour and 15. So just put 11:51, and this will be at 4 hours. There we go. All right. Well, I'm gonna go to the gym, go take care of some business, and I'll be back later. All right, guys. We got it figured out. We're gonna next session. We're actually going to begin implementation. Finally. So there it is. SQL with wall mode and begin transaction, and bam, there we go. All right. See ya.